All right, welcome back, everyone. Hopefully, you've had a good week. Today, we're going to look at this fancy term called trigonometry. Is basically geometry again. Sorry, we have to go back to geometry. We done that like a month ago, but now we're back to geometry. But this is a special kind of geometry, and we'll learn why. Right, we have some more people coming in as well. I think you're still missing a few, but that's all right. So let's go to our next slide. Here. So we need to know first what trigonometry actually is. It's just the geometry of triangles. You're trying to find relationships between sides and angles with special special identities. You'll learn about them in the next slide. There's a lot of applications with trigonometry, including like astronomy, like finding like the orbital angles, like the orbits of planets. Okay, we have more people coming in. And they also have application in optics, so like the science of like the eye and light, stuff like that. And trigonometry is famous for like its various identities. So what I mean by identities is that you can make lots of equations that can show lots of relationships between sides and angles. And so we will look at some of them later in this slide. But let's look at the main trigonometry ratios. So say you have a right angle triangle. It has to be a right angle triangle, otherwise these don't work. So in a right angle triangle, you have three sides, right? But these three sides can have different names. So you have AC over here and BC. They're the two shortest sides of the triangle. Don't worry about the opposite and adjacent names for now. We'll look at those later. So these are the two shortest sides of the triangle. They're called the legs. But then the longest side of the triangle, it has a name called the hypotenuse. So just remember that. The longest side of the right angle triangle is called the hypotenuse. In this case, it's AB, or you call it side C. Yeah, so we're gonna actually name these sides by the lowercase letters. So this side is A, this side is B, and then this side is C. Okay, and now we'll look at the trig ratios. So our first trig ratio is called sine. So it's spelled S-I-N-E. So we're gonna look at angle A specifically. So this angle right here. I should have named it BAC, but it's okay. We're gonna look at this small angle right here between B and C. Okay, so sine of A, this is always equal to, so in a right triangle, this is equal to the opposite side divided by the hypotenuse. I like the lengths. The length of the opposite side. So you can see here, the opposite side of angle A is lowercase a itself. Here's the opposite side. It's labeled right here. And then you divide it by the hypotenuse, which is the longest length in the triangle. So sine of angle A is equal to this ratio right here. That's why it's called ratio, because it's a fraction. So opposite divided by hypotenuse is also equal to A divided by C. Let's look at our next trig ratio. Cosine. Our next one is called cosine. So you have sine, but you just add a CO in the front, cosine. So cosine of angle A right here is equal to adjacent. So the adjacent side, so like the side that touches it, but it's not the hypotenuse, it's one of the short sides. One of the short sides that touches it is called the adjacent. So in this case, it's side length B right here. This is the adjacent, it touches the angle. And same with sine, you divide that by the hypotenuse. So, side length C. So this is equal to B over C. So that's what the cosine ratio is equal to, adjacent over hypotenuse. And finally, we have tangent. So tangent of A, now we don't use the hypotenuse. We just look at the opposite side. So the opposite side of angle A is just this side, and divided by the adjacent side. So the adjacent side is B. So I made a typo. A divided by B. There you go. All right. Yep. Okay, so tangent of A is just opposite side divided by the adjacent side, which is equal to A over B. And if you notice, we can look at these simplified ratios and we can manipulate them a little bit to get this property. We get tangent of A is equal to sine of A divided by cosine of A. And if you can see why, I'll just I'll prove it on a whiteboard right here. So we had sine of A equal A divided by B. C. Cosine of A is equal to B divided by C. Tan A is equal to A divided by B. So we want to prove that tan A is equal to sine of A divided by cosine of A. So we can just substitute these values into here. So tan of A is A divided by B is equal to, let me write this out because fractions, yeah. So tan of A is A divided by B. Sine of A is A divided by C. Cos of A is B divided by C. We can simplify the left side. So we can, well, yeah, let's rewrite this as A divided by C divided by B divided by C using the division symbol instead of fraction. So yeah, now we can just cross multiply. Now, now we multiply by the reciprocal, so multiply by C over B. And yeah, here you cross multiply, so we get rid of the C's. And then you're left with A divided by B. So the property holds true. There you go. That's how you prove it. Tan A is equal to sine A divided by cosine of A. And this works for other angles as well. All right, give me a thumbs up if you understand these ratios. Sounds good. Let's move on. Okay. Now we looked at these special triangles like a month ago when we were still learning about 2D geometry. And at that time, we didn't really explain like why they had these side ratios for these specific angles. So we looked at one triangle called the 30, 60, 90 triangle. So it has a 30-degree angle, a 60-degree angle, and also a 90-degree angle. We also have another special triangle called the 45, 45, 90. So it has two 45-degree angles and one 90-degree angle. And these triangles have these special side length ratios. So you have say x at the bottom here, and then x square root 3, and then 2x. And this works for any value of x, any real number value of x. And for here, you have x over here, x times square root 2. And this ratio will always work for any value of x as well. All right, so let's explain these ratios that I have on the sides. So let's look at sine of 30 degrees. So we're going to look at sine of this angle right here. So remember that sine is opposite length divided by the hypotenuse length. So in this case, it would be x divided by 2x. Here, x is the opposite side from 30. See, it's the opposite. And then 2x is the hypotenuse, the long side. So sine of 30 degrees would be x over 2x, which is 1/2 for any value of x, right? You just cross out the x in the fraction and you get 1/2. Now cosine of 30 degrees, you take the adjacent side, so x times square root 3, divide that by the hypotenuse length, which is 2x. So you take x square root 3 divided by 2x, and you can simplify that to square root 3 over 2. Okay. Now tangent of 30 degrees. we take the opposite, divide that by the adjacent. So x divided by x square root 3. And that simplifies to 1 divided by square root 3 if you cancel the x's. Now, this is also equal to square root 3 over 3. If you guys haven't heard about this strategy called rationalizing the denominator, it basically means, so rationalizing the denominator just means that you want to take the square root out of the denominator and put it into the numerator. So the way to do that, you just multiply the denominator and the numerator by both by square root 3. Basically, just multiplying it by 1 and stay the same, but you're changing the denominator and the numerator, even though it's still the same fraction. So if you multiply the denominator and the numerator by square root 3, you get square root 3 over 3. Give me a thumbs up if you understand how I got from here to here. Okay, yeah, this is very important, so I'm glad you guys understand. Okay, let's look at sine of 60 degrees. So take the 60 degrees. And remember, sine is opposite over hypotenuse. So the opposite side of the 60 degrees, it's no longer x. Now it's x square root 3. So we're looking at this side. So x square root 3 divided by 2x. And that's simplified to square root 3 over 2. Now let's look at cosine of 60. That's the adjacent divided by hypotenuse. So x divided by 2x. Here, x is the adjacent side of 60. So the opposite sides and the adjacent sides will be different depending on like the angle that you choose. Well, you can't choose a 90-degree angle. You have to choose either this angle or this angle over here. But opposite adjacent can swap around depending on the angle you choose. So cosine 60 is just x over 2x, which is 1/2. Now tangent of 60 degrees, I think I made a mistake here, is just this square root 3. There you go. Right, tangent of 60 is opposite divided by adjacent. So we have x times square root 3 divided by x. If you get rid of the x's, it becomes square root 3. And that's what tangent 60 is equal to. Okay, now let's look at the 45, 45, 90 triangle. Let's look at sine of 45 degrees. So it doesn't matter which angle we choose, it's the same. So sine of 45 degrees is opposite divided by hypotenuse. Here, let's choose the top 45 degree over here. So sine of that would be x, this x right here. I mean, we could have done this x as well, but we're going to stick with the opposite side, which is this x, and divide by the hypotenuse, which is x square root 2. You simplify that to 1 over square root 2. And once again, we can rationalize the denominator to multiply both sides by square root 2, and you get square root 2 over 2. Cosine of 45 is equal to the same thing, right? Because you're choosing the opposite side is equal to the adjacent side. So they're both x in this case. And so you get the same ratio, square root 2 over 2 for 45 degrees. Now tangent of 45 degrees, that's opposite over adjacent. Since the opposite is equal to adjacent, that means the ratio will be equal to 1. So give me a thumbs up if you understand these special ratios. Give me a thumbs up if you understand how I got these numbers right here and right here. Okay, looks good. That's a lot of thumbs up. Let's look at a sample problem. Find the value of h in this triangle. Shouldn't take you too long. And there's multiple ways to solve this. I think I gave you way too many values here, but let's solve it the trigonometry way, actually. Okay, I'll get out the whiteboard. Okay, we're going to solve it using a trigonometry way. So we want to use a ratio that relates the h with the hypotenuse length, which is 6. Here, let me draw a triangle again. You know what, never mind. I won't draw a triangle. It's going to be too complex with this software. Okay. So, I mean, all you need to know is that, so 6 is this length right here. Oh, sorry, h is the height. The hypotenuse is 6. There you go. And I believe there was an angle right here. It was 30 degrees. Okay, this angle right here is 30. The length right here is h. That's what we want to find. And we have 6 right here. So we have h. We have 30 degrees over here. We have 6 over here. Oh yeah, and we also have a right angle. That's very important. There's a right angle right here. We don't really care about this angle or this side for now. So we want to use one of our trig ratios, so sine, cosine, tangent, to relate h, 30 degrees, and 6. Can someone tell me what this ratio is? So type sine, cosine, or tangent in the chat. So which one will we use? Good, cosine. Remember, cosine is adjacent divided by hypotenuse. So let's look at where the angle is. So it's 30 degrees. 30 degrees is between the hypotenuse, which is 6, and its adjacent side, which is h. H is the adjacent side because it's touching the 30-degree angle. So this ratio would be adjacent over hypotenuse. And this ratio is equal to cosine. So we will use this property. So we have, I'll write it out. Let's draw. So we have cosine of 30 degrees is equal to, so we said adjacent over hypotenuse. Adjacent is h, hypotenuse is 6. And from our last slide, we got an exact value of cosine of 30 degrees. And if you guys remember, it should be square root 3 over 2. This was from the last slide. So square root 3 over 2 is the exact value of cosine of 30. Now we can set this equal to h over 6. And now we can solve for h. We just multiply both sides by 2. Sorry, by 6. Multiply both sides by 6. So if you multiply here by 6, multiply here by 6. Here you get rid of the 2, this becomes a 3. So now we get h is equal to 3 square root 3. Right? Give me a thumbs up if you understand this question. Okay, sounds good. Let's move on. There you go. Let's look at doing trigonometry on a graph or a Cartesian plane. So say we have a side length with length r, and it goes to this point x comma y. So this is not like a line that reaches forever. It's a line segment that has 2 points that determine how long it is. Right, so it starts from the origin 0, 0, and goes to this point x comma y. Okay, so now, and we have this angle theta. And this angle theta is made with the positive x-axis. So from the positive x-axis to r, that angle is called theta. And yeah, this is a Greek letter that mathematicians use to to represent like an angle as a variable. They usually use theta, not like x or y. They use theta to represent angles. And you'll see that a lot in the slideshow as well. But so let's look at the trig ratios in this diagram. So we have sine of theta. So sine is opposite divided by hypotenuse. So sine of theta would equal to y, so that's the opposite side, divided by r, so this side right here, the hypotenuse, which is r. Cosine of theta is adjacent divided by hypotenuse, so x divided by r. Now tan of theta, that's opposite divided by adjacent, so opposite side is y, divide that by the adjacent side, which is x. Now what you notice here, you can also use the Pythagorean theorem. So remember, this is a right angle triangle. Your right angle is right here. So the angle that's made with y and x is 90 degrees. And so you can use Pythagorean theorem to calculate r. So you would write r squared is equal to x squared plus y squared. And then you can simplify. If you want to solve for r, you just take the square root of both sides. So now you get r is equal to square root of the sum of x squared and y squared. Okay, so give me thumbs up if you understand this. It says give me a thumbs up if you understand this. So how to use trigonometry on a graph. So we choose some random point x, y, and we just draw a line from the origin to that point. And we can use these ratios right here. So that's all you need to know. And we'll use this in the later slides. Right. So we're going to look at these four triangles right here. They all have an angle of 30 degrees, but they have different orientations. So they're like all rotated. Like one is in the positive x and y axis. Another one is with the negative x but positive y axis. There's one with the negative x and negative y axis. And then the last one is with positive x and then negative y axis. And these sections, they're called quadrants. And there's 4 quadrants in a Cartesian plane. So the one with positive x and positive y, this is called quadrant 1. And now let's look at the trig ratios with this triangle right here. So sine of 30 degrees, that's still 1/2, so 1/2. Cosine of 30 degrees is still square root 3/2. Oops, sorry about that. And tangent of 30 degrees is just 1/square root 3. Okay, now let's move on to quadrant 2. So quadrant 2 is with the negative x-axis, but the positive y-axis. So we're basically just reflecting this triangle off the y-axis to get this triangle. Now you notice there's something different. This side is negative now. Like it's not a negative length, but like because it's a negative x-axis, it's the negative x-axis. We're going to make this side length negative. So like the point right here would be negative square root 3, comma 1. Hopefully that's clear. So we're going to use the point x, y, like the signs of x and y, to determine our trig ratios instead of just all positive sides. So we have sine of 150 degrees. So why 150 degrees? So we're looking at the angle. We're not looking at the angle that's like closest to the x-axis. We're looking at the angle that's made with the positive x-axis. So this side right here, it'll be over here, and we're looking at the angle where it goes counterclockwise. So this way until it reaches the hypotenuse right here. So that angle right there is 150 degrees. And so we have sine 150 degrees is still 1/2. Now here's something different. Cosine of 150 degrees, it's negative 3/2. Remember, cosine of 150 degrees from our last slide is x over r. So, whoops, didn't mean to go back. So remember, here x is negative, and r always stays positive. R is a side length; it has to stay positive. But x can be negative, so it means if you take a negative number divided by a positive number, you get a negative ratio. So that's why this is negative square root 3/2. Now tangent of 150 degrees is y over x. So the y length divided by the x length. Remember, the x length is negative, but the y length is positive. So that means you're dividing a positive number by a negative number, and you get a negative, sorry about that, you get a negative ratio. And if you notice how 150 degrees is related to 30 degrees, it's basically 180 degrees minus 30 degrees. And so this property will be useful later on. But just notice like the relationship between all these angles with the 30-degree angle. Okay, so this is for quadrant 2. Now let's look at quadrant 3. So this is made with negative x-axis and the negative y-axis. We're going to look at the angle of 210 degrees. So because remember, we're making the angle counterclockwise and has to start from the positive x-axis, and it has to go all the way until it reaches the hypotenuse, which is r in this case. And so the angle would be 210 degrees in this case. If the angle right here was 30, that means this whole angle is 210. You can probably see why. So let's look at sine of 210 degrees. So remember, that is the y length divided by r. So remember, r stays positive always, but since the y is negative, the ratio will be negative. So this is negative 1/2. Now cosine at 210 degrees, it's x over r. Remember, the x length is negative and r stays positive. So you divide negative by positive, you get a negative ratio. So negative square root 3 over 2. Oh yeah, notice that when you align all of these together, so you align the cosines of all of these angles, the sine of all of these angles, if you take the absolute value of all of them, they're going to be the same. If you take the absolute value of all these values, they're going to end up with the same value. So you see they're all 1/2 for sine, square root 3 over 2 for cosine, and then for tangent is always 1 over square root 3. Okay, and then tangent of 210 degrees, so you're dividing y by x. And since they're both negative, that means you get a positive ratio. So you end up with positive 1 over square root 3. Right. And how we get 210 degrees from 30 degrees, you just add 180 degrees. So, like a straight line to get from 30 to 210. Now let's look at quadrant 4. Quadrant 4 is made with the positive x-axis, but the negative y-axis. And we're going to look at the angle 330 degrees. So that's the angle made with positive x-axis, and if you rotate counterclockwise, all the way to the hypotenuse, that's 330 degrees. Let's look at sine of 330 degrees. So sine is y over r. Remember here that y is negative, so it's negative 1 here. And so that means, and then r is always positive, which is 2. So you divide both of them, you get negative 1/2. Cosine of 330 degrees. So that's x over r. Here x and r are both positive. So that means the cosine ratio is also positive, which is square root 3 over 2. And now tangent of 330 degrees. This is equal to negative 1 over square root 3. So because y is negative, but x is positive. So to divide negative by positive, you get a negative ratio. That's negative 1 square root 3. And then to relate 330 degrees with 30 degrees, you take 360 degrees. So 360 degrees will be a full rotation. And you subtract 30 degrees. So this angle right here to get to 330 degrees. So give me a thumbs up if you understand these ratios right here. So the most important thing to note is like notice like how there's for quadrant 1, all of the ratios are positive, and for the other quadrants, some of the ratios are negative. So take that in mind. Okay, so here we're going to look at some notes. So remember in quadrant 1, so over here, look at the positive x and y axis, that's quadrant 1. All the trig expressions, so sine, cosine, tangent, they're all positive. Remember from the last slide, we got, look at these, they're all positive. Now let's look at quadrant 2. So the positive y-axis and the negative x-axis right here. So in that quadrant, only sine is positive. It's because y and r are the only sides that are positive. Remember, the y is positive, r always is positive, but x is negative. So I mean, any trig ratio with an x will be negative. So remember, y over r, they're both positive, so only sine is positive. In quadrant 3, only tangent is positive. Now this is a special case because y and x are both negative. So this is where quadrant 3 is. It's negative x and negative y-axis. And since they're both negative, you divide negative by negative, and you get a positive ratio. And if you have anything with r, that means you're dividing a negative by a positive side. So you'll always get a negative side for sine and cosine in quadrant 3. And now in quadrant 4, so negative y and positive x, so the bottom right corner, only cosine is positive because x and r are the only side lengths that are positive. Only values that are positive. I shouldn't say side lengths, I should say values. So give me a thumbs up if you understand these points right here. Okay, see a few thumbs up, but this is kind of a confusing concept for you guys to learn right now. You actually only learn you only actually start learning trigonometry in grade 10, but like only a little bit. You actually start learning trigonometry in more detail in like grade 11. But I'm teaching it to you guys right now, so you can get a good head start on it. So hopefully these notes are clear. So hopefully these points here are clear. So remember, all the trig ratios in quadrant 1 are positive. Sine is positive here. Tangent is positive on over here, so negative x, negative y. And cosine is positive over here. So just remember that. Okay, we're going to have this new term called the related acute angle. In short term, we'll just call it the RAA, whatever we use it. So this related acute angle is the smallest angle made with the x-axis. So it can be the positive x-axis, or it can be a negative x-axis. We're just looking at the smallest angle that it makes of that. So for example, from this diagram here from 2 slides ago, we see that the related acute angle is 30 degrees. It's not 210 degrees. That would be too big. We're just looking at the 30-degree angle. That's the related acute angle that we want. Now, here's another note. So trigonometry expressions, so sine, cosine, tangent, if they have angles that are larger than 90 degrees. So 90 degrees would be if they reach all the way to the positive y-axis over here. So trig expressions with angles larger than 90 degrees, or even smaller than 0 degrees. Yeah, so you can have angles that are smaller than 0 degrees. So you can have negative angles, just depending on like the orientation that you look at. But we don't look at those. We don't focus on negative angles too much. Let's focus on angles that are larger than 90 degrees. So they can be expressed using this related acute angle instead. So for example, we cosine of 150 degrees. I'll want to simplify that using the RAA. So if you look at this diagram right here, so we want to find cosine of 150 degrees. So here we found out it was negative square root 3 over 2. And so that means it will be the negative of its RAA. So its RAA is 30. Its related acute angle will be 30. That's the closest angle made with the x-axis. In this case, it's a negative x-axis. And so this ratio here in the quadrant 2 would be negative. Like if we look at it in quadrant 1, it would be positive. So I mean, let's go back. So cosine of 150 degrees would be negative, would be the negative cosine of its related acute angle. And this related acute angle, remember, it's always between 0 degrees and 90 degrees. It can never be larger than that. And so it'll be equal to negative cosine of 30 degrees. And this makes sense because we learned from this slide that In quadrant 2, so where 150 degrees is located, only sine is positive. So that means cosine is negative in that quadrant. And so it makes sense for it, this ratio to be negative. So give me a thumbs up if you understand these notes. Okay, sounds good. Let's move on. I have a few problems here. So find the value of the following trig expressions. So you're going to have to find the related acute angle for each of them and figure out whether it's like positive or negative depending on the quadrant it's in. So we're going to look at these together because we're running a bit out of time. So first one is sine of 120 degrees. We'll write that down. All right. So I want to write this with its RAA. Instead of using 120 degrees as the angle, I want to use its related acute angle for the input for sine. And so 120 degrees is in quadrant 2. It's with because. So you're starting from here and go over here. That's about 120 degrees. And this is quadrant 2. And quadrant 2 is where sine is positive. So that means we don't need a negative sign right here. We just keep it as sine of RAA. Can someone tell me what the RAA is equal to? So the angle that's made with the closest x-axis. So you can look at that 180-degree angle, or you can look at that 0-degree angle and see which like angle difference is smaller. So what is the RAA in this case? So you can do 180 subtract 120 degrees, or you can do 120 degrees subtract 0 degrees. So which one is smaller out of those two? And that will be your RAA. Yeah, so 180 subtract 120 is smaller than whatever 120. 180 subtract 120 is smaller than 120 itself. That's what I'm going to say. And so 180 subtract 120, that's 60 degrees. So sine of 120 degrees is equal to sine of 60 degrees then. And if we look from a few slides ago, we got the exact value of sine of 60 degrees. If you guys remember clearly, it's just square root 3 over 2. I'm just going to write it out. Yeah, so we got the exact value of sine of 60 degrees. We don't have to like calculate on our own. We just use the exact value we got from a few slides ago. And that's square root 3 over 2. Let's look at our next question. Tangent of 225 degrees. So we want to express this with, it's either positive or negative, but we want to use the related acute angle instead of 225 degrees. But yeah, and for each of the questions that I give for this slideshow today, the angles, so like the related acute angles, are either going to be 30 degrees, 45 degrees, or 60 degrees. I think I could give you like 90 degrees or 0 degrees as well, but just to make life simpler, the RAA is either going to be 30, 60, or 45 degrees. Okay. So can someone tell me what the RAA is for this question? Good, 45. So the closest x-axis will be the negative one. So 225 is all the way down here. It's in quadrant 3. And so it'll be closer to the negative x-axis than the positive x-axis. So we just do 225 subtract 180. And that will be our RAA. So this is equal to tan of 45 degrees. And we also need to check whether tangent is positive or negative in that quadrant. So it's in quadrant 3, where y and x are both negative. So if we divide both of them, so that's the property of tangent, you get a positive ratio. So tangent of 225 is equal to positive tan of 45 degrees. Now, can someone tell me what tangent of 45 degrees is? If anyone remembers correctly, what's tangent of 45 degrees? So we can look back at the slide from, or someone remembers it. 1. Yeah, here, I'll show you guys that slide so you guys can remember the special trig ratios. So over here. So if you guys can write these down, that would be great. I'll give you guys some time to write these down. Yeah, so when you write these down, so whenever we solve a question, you can just substitute that trig ratio with its actual value, just to make life simpler. Yeah, just take a screenshot too if you want. All right, give me a thumbs up if I can move on. So like if I can go back to the question. Okay, good, Kevin. Does anyone else need this slide, or are you all good? Oops, sorry about that. Okay, sounds good. Let's go back to the question. So yeah, we just substitute our value of tangent of 45 degrees with the actual value from that slide, and it was equal to 1. Oops, didn't mean to do that. Oh, come on. Here. Okay, tangent of 45, that's equal to 1. Okay, so that's our second problem done. Let's look at our third problem. Cosine of negative 30 degrees. Did not mean to misspell that. Okay, I'm going to draw this out so it looks clear to you guys. So we want to find cosine of negative 30. So remember that these angles are made with the positive x-axis. And if they're positive, they go counterclockwise. If they're negative, they would go clockwise. In this case, it would go clockwise. So the angle would look, oops, that means that. The angle would be around here. This would be negative 30 degrees, right here. Okay, can someone tell me what the RAA is equal to? So what's the RAA here? We're looking at the angle made with the closest x-axis. And here, the closest one would be this one. So what's the angle over here? It should be obvious. What's the RAA? Can someone tell me? So what is this angle supposed to be? From this side to this side. What is that angle? It's obvious. It's like written right here. It's 30 degrees. So negative 30 would go clockwise instead of counterclockwise. It goes over here. And that is also the really acute angle. So like the angle made with the x-axis. It's also 30 degrees. So we look at cosine of 30 degrees. But we also need to check if it's positive or negative. This is quadrant 4. So in quadrant 4, cosine is positive. So we don't need a negative sign here, and we're good. Now we just need to figure out what cosine 30 degrees is. And from that slide, we got the exact value of it, which is square root 3 over 2. Just write out. cosine 30 degrees is square root 3 over 2. Okay, that's our third question solved. So go our fourth one. Sine of 180 degrees. Okay. Now this one, we don't really need to figure out the RAA, but we can use the property that sine is equal to the the y coordinate divided by the length of r. We can use this property. And what you notice, so sine of 180 will lie on the x-axis. On the x-axis, y values are 0. So this would be equal to 0 over r. And yeah, it's just equal to 0. There you go. Sine of 180 degrees is equal to 0. So give me a thumbs up if you understand these questions. Okay, sounds good. Let's go back to our slideshow. Okay, so now we're going to look at some trig identities. So our first one is sine squared of x. So this is basically, so I put, usually we'd put the squared in front of the sine and not like the x. Otherwise we think that like the x is squared instead of the whole thing squared. So in this case, we look at sine x and we multiply it by sine x. That's equal to sine squared of x. And same thing for cos squared of x. So now we want to simplify sine squared of x plus cos squared of x. Now we're going to use substitute them with the coordinate ratios. So y, x, and r. We're going to express them using y, x, and r. So we substitute sine of x into here. Sine of x is y over r. So it's equal to y over r, all that squared. Same thing for cosine. Cosine is x over r. And we just take that whole thing and square it. And now we can simplify this to this expression right here. So because the denominators stay the same, so the denominators are r squared, we can just directly add the numerators. So we can just add y squared plus x squared and divide that by r squared. If you notice here, we can substitute y squared plus x squared. Sorry about that. We substitute y squared plus x squared with r squared because we're using the Pythagorean theorem. Remember that the hypotenuse is equal to, hypotenuse squared. So like a squared is equal to b squared plus c squared. Or like a squared plus b squared is equal to c squared. However you want to memorize it. But yeah, so y and x are the short sides, and then r is the hypotenuse. So therefore you can rewrite this as r squared. And if you divide r squared by r squared, you just get 1. So therefore sine squared x plus cos squared x is equal to 1. Give me a thumbs up if you understand how I got this. I think most of you are a bit confused, like how I got y squared plus x squared to r squared. So let's go back a few slides. It was over here. So you can look at, this is our 90-degree triangle. So that means that x squared plus y squared is equal to r squared according to the Pythagorean theorem. So x squared plus y squared or y squared plus x squared is equal to r squared. And we just substitute it over here to get r squared in the numerator. Okay, let's look at another property. We can relate sine with cosine with using these two properties. So sine of x is equal to cosine of 90 degrees minus x. And similar for cosine, cosine of x is equal to sine of 90 degrees minus x. And we can see this from this example right here. So say you have a right angle triangle with side lengths ABC. Oh, we don't really care about ABC. We just care about the angles. So we have 90-degree angle. Say we have an angle theta right here. Now, if we were to algebraically solve for this angle, we would get 90 minus theta, right? Because 90 minus theta plus theta is 9 degrees, and 90 degrees plus 9 degrees is 180. And so if you look at sine of theta, so we're not going to use x, we're going to use theta. So sine of theta would be a over c. So opposite divided by hypotenuse, a over c. Okay, now let's look at cosine of 90 minus theta. Cosine is adjacent. The adjacent side is a. Hypotenuse is c. So this is also equal to a over c. So that means sine of x is cosine of 90 minus x. Same thing for cosine of x. Cosine of theta, here is b over c. This is the adjacent side. Sine of this angle right here is opposite divided by hypotenuse. Is opposite is also b. So that means these two trig ratios are equal. Give me a thumbs up if you understand these. Okay. Hopefully that's clear to you guys. I will move on. Now let's look at these trig identities. This might seem really intimidating to you guys, but so say we have sine and cosine, and inside the brackets, so like the input we're taking is the addition of two angles. So we look at sine of like a plus b. Say these were the two angles that we want. Same for cosine, a and b. Sine of a plus b is equal to this. Sine of a plus b is equal to this identity right here. So we have a sum of sine a cos b plus cos a times sine of b. So I should have spaced these out, but so the a is the angle that goes with sine. Over here, b is the angle that goes with cosine. And we're just multiplying sine with cosine over here. In this case, a is the angle that goes with cosine, and then b is the angle that goes with sine. And we just multiply those two values right there. And a similar thing for cosine. Cosine looks a bit different. You multiply the two cosines and subtract that by multiplying the two sines, sine a, sine b. And then subtraction, you just switch around the signs over here and over here. And if you actually want to prove this, you can use the diagram here on the right. It's a bit confusing to explain it right now, but I can try a little bit. So basically they just made a rectangle, and inside the rectangle, they drew a 90-degree triangle. And then they gave names to some of the angles. So they gave the angle here alpha. Notice I have A, we're calling it alpha. That's the Greek letter for A. Okay. That looks like A. And here, this angle here, they named it beta or B, whatever you want to call it. And so they use these angles to calculate the side lengths. So you don't really have to understand like how these side lengths were calculated, but it shouldn't be too bad to understand how they were calculated. Oh yeah, and also an important note that this side length here is 1. Yeah, they set this side length here equal to 1. And by setting that equal to 1, you can get all these all these lengths right here. But if you can understand like how we got these side lengths, that would be a great bonus. But like, let's say we want to get sine of a plus b. So sine of these two angles add together. Now you see that here there's no triangle that's made with both of these angles right here, but we can draw one. So say you want to draw a line from this point right here all the way to this side length, and they would intersect at a right angle. So from here to here. So you want to calculate sine of a plus b. Oh yeah. So sine of a plus b. That would be opposite divided by hypotenuse, right? So the opposite side is actually this line that we draw right here. And that line is equal to this line over here. So like the height of the entire rectangle, that would be the opposite side. And so you can figure, and you can see that that's equal to sine a cos b plus cos a sine b. Okay. And if we want to find cosine of a plus b, Oh yeah, right. You have to divide that by the hypotenuse, but since the hypotenuse is 1, it would just be equal to that sum right there. Simplifying for cosine a plus b. So cosine will be this bottom length right here. If we were to draw this side length, it will be over here. So from here to where those two side lengths intersect, and that will be cos a cos b minus sine a sine b. And you divide that by 1, it just stays the same. So it's equal to that. And for sine a minus b, cos a minus b, you switch the sign around. So give me a thumbs up if you sort of understand how these how to prove these trig identities. Like, you don't have to understand like how these how they got these side lengths. If you can understand that, that would be really great. But just, I don't know, memorize these identities if you can. It'll be very useful when you try to calculate like a sine of like a different angle that's not like 30, 45, or 60. It's okay, sort of understand is good enough. Just know these identities like in your head or something. So remember, for sine, you have sine times cosine, and you plus cosine times sine of these two angles. So a always goes first. So you have, for sine of a plus b, you have sine a, that goes with cos b. And you add that with cos a sine b. And for cosine of addition of angles, or subtraction of these two angles, you take both the cosines, multiply both the cosines, and subtract or add by the sines. So that's one way you can memorize it. We're going to end this with some more problems. So let's look at this one. If sine x is equal to 1/4, find the value or values of tan x. And we're just going to do this right now because we're running out of time. Sine x is equal to 1/4. Actually, no, we'll call this sine a because we're going to use x, y, and r to solve this problem. We're going to use the x coordinate, y coordinate, and the length of r. So we don't want to get like, the x coordinate and then the angle x mixed together. So remember that sine of like any angle is equal to y over r from a Cartesian plane perspective. So that means, oh, oops, how did those come back? Sorry about that. Okay. So we add this. So we can set values for y and r then. So we can get y is equal to 1 and r is equal to 4. So if we set this, fraction equal to this fraction right here, this is one solution for y and r. Like, this isn't the only solution, but it's probably the simplest one you can think of. So y is 1 and r is 4. Remember that tangent is equal to y over x. We need to find what x is over here. We have y and we have r, and we can solve for x if we use the Pythagorean theorem. Remember that x squared plus y squared is equal to r squared. We can substitute values for y and r. So 1 squared, that's just 1, is equal to 4 squared, which is 16. X squared is equal to 15. So that means, and I will draw it right here. So that means x would be equal to square root of 15. And actually, oh my God, I didn't mean to do that. Can I? Good. Sorry about that. Okay. X can be both positive and negative. So you can take either the positive x-axis or the negative x-axis. They both work. Remember, when you square root something, you have to take the plus minus of that square root. So you get two solutions. So we have x is equal to plus or minus square root 15. Now if we want to solve for tan of a, yeah, it covered the writing, but it'll show up once I exit out. So remember, x is equal to plus minus square root 15. I will, just write it out as well. So we just substitute value of y and substitute value of x. So this will be equal to 1 over plus minus square root 15. All right. And if you want, you can rationalize the denominator. Now let's put the plus minus outside. So like in front of the fraction. And if you rationalize this, you get this. Plus minus square root 15 over 15. So we multiply denominator and numerator by square root 15, and you get this. So give me a thumbs up if you understand how to solve this problem. So to solve these problems, if you're given, so this problem, you are given one trig ratio, and then you want to find another trig ratio. Here we're given sine, and we want to find tangent. So you would want to use the values of y, x, and r, and try to calculate what those are. Even though they have multiple solutions, you just want like the simplest solutions of x, y, and r. And once you get those, you can find any trig ratio you want. Yeah, no, it's 101. Or I think we can do one more problem. The next one is really important for you guys to know. So give me a thumbs up if you can stay for like 1 or 2 more minutes. We're gonna solve this problem really quickly. It's very important that you guys know how to solve this as well. It'll be on the homework. Yeah, there's a couple of these problems on the homework, so it's important that you guys need to know how to solve this. So we want to find the exact value of sine of 105. Now, if we try to find the related acute angle of 105. So remember that 105 is in quadrant 2. So it will be closer to the negative x-axis instead of the positive x-axis. So that means its related acute angle would be 180 subtract 105. But that's equal to 75. But we don't know how to because we've never solved for like the trig ratios for 75-degree angle. So we don't know how to get the exact value, but we can use the properties of like adding and subtracting angles that we had like 2 slides ago. So we had like sine of a plus b or a minus b. So we want to express 75 using 2 angles. So like the sum of 2 angles. And it's possible to do that. So we're trying to find sine of 105. And remember, this is equal to sine of RA. We got the RA equal to 75 degrees. And then this is also positive ratio because sine in the quadrant 2 is positive. Okay, now we can express this. So we want to express 75 with 30, 45, and 60-degree angles. So I actually want the sum of 2 angles. Can somebody tell me what 2 angles I should use? So what values of A and B should I use? So remember, A and B should either be 30, 45, or 60. I want the sum of 2 angles. So sum of 2 of those 30, 45, or 60 angles equal to 75 degrees. Can someone tell me how to do that? Perfect. So we can have 30 degrees and 45 degrees. So 30 plus 45 is 75. And I will write down the, what is it? What the addition is equal to. So sine of a plus b, like what sine of a plus b is equal to. So it's equal to this sum right here, if you guys forgot about it. So we have sine of a, sine of the first angle, times cosine of the second angle, plus cosine of the first angle, times sine of the second angle. So here a is 30, b is 45. And we'll do it over here as well. And now we can substitute these their exact values into these expressions right here. Because we know what sine of 30 is, we know sine of 45 is, we also know what cosine of 45 is, we also know what cosine of 30 degrees is. So that's why we express the sine of 75 using these two angles right here. Because that question asks for an exact value. Now we will substitute. So probably better to write this out because there's lots of fractions. So sine of 30 is 1/2. Cosine of 45, square root 2/2. Plus cosine of 30, that is square root 3/2. Oh yeah, in the homework that I give you, I will give you, in homework, I already typed out like the exact values for the special trig ratios. So you guys can just refer to that section of the homework if you want to, if you forget like what the ratios are equal to. But now let's finish up this question. Okay. Now if you want to simplify, we just multiply those fractions together. So this is square root 2/4 plus, now square root 3 multiplied by square root 2, you can just multiply like whatever's inside the square root and just merge them together. So we can merge square root 3 and square root 2 as square root 6. So 3 times 2, which is square root 6. And then the denominator is 4 as well. Multiply 2 by 2, right? And then we can't really simplify this any further, except that we can just add the denominators and numerators. And we just leave it like that. So square root 2 plus square root 6, all of that divided by 4. So give me a thumbs up if we understand how to solve these problems. This problem. Because this problem will show up a few times in the homework. So it's pretty important for you guys to know how to solve it. So just use, just find like an addition or subtraction of two angles that are like related or equal to 30, 45, or 60, and then you're good. Okay. And there was another problem, but we won't do that today. I won't cover it today. It's just basically solve for x with this cubic equation right here. You want to first, you can substitute about, so if you want to solve this, you can substitute like a variable for sine of x, and then just try to solve for that variable in that cubic equation, and then set that variable equal to sine of x, and then solve for x. So that's a hint if you want to solve this problem. And I will share it with you guys later today. But for now, I will end the meeting. So thank you guys for participating in today's session. And I think we will have one more next week. It'll probably be like a fun one. And then we'll call it good for this school year. So hopefully you guys enjoyed today's lesson. Yep, thank you. Yep, goodbye everyone. So thanks for coming, and we'll see you next week. Goodbye.